Determine the limit as x approaches positive infinity of sine of x divided by x. For the limit as x approaches positive infinity of sine of x divided by x, the first thing to do is plug a positive infinity in for each of the x's, which will give a sine of positive infinity divided by positive infinity. The sine of positive infinity is indeterminate due to oscillation, but it will remain finite somewhere between -1 and +1. Since it's being divided by positive infinity, this limit should exist and can be found using the squeeze theorem. Starting with the sine of x, which sits somewhere between -1 and +1. Our function for the limit we want to determine is sine of x divided by x. We will now divide each of these by x, and the inequality will still hold true. We can now take the limit as x approaches positive infinity of each of these, and the inequality will still hold true. Starting with the leftmost limit, each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. So that limit will be a 0. The middle limit is indeterminate due to the sign of positive infinity, so we will leave it alone. The rightmost limit, each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity, so that one will also be 0. And the middle limit is now being squeezed between 0 and 0. And therefore the limit as x approaches infinity of sine of x divided by x has to equal 0 due to the squeeze theorem, and we have determined the limit as given.